Welcome to our exploration of smart manufacturing, a revolutionary approach that's transforming industries worldwide. It merges advanced manufacturing techniques with innovative technologies like artificial intelligence and the Internet of Things. This fusion not only optimizes production processes, but also enhances product quality and boosts manufacturing efficiency. As factories become more automated and data-driven, productivity improves, allowing manufacturers to adapt quickly to market changes. Smart manufacturing, a core component of Industry 4.0, signifies a new era of technology-driven industrial practices. The future of education in this field is vital, preparing upcoming engineers and technicians with the skills needed to innovate and excel in this evolving landscape. Today we delve into the components of a comprehensive 30-credit course in smart manufacturing, covering essential technologies, applications, and ethical considerations. Let's trace the roots of smart manufacturing back to the third industrial revolution, marked by the onset of computers and automation in factories. Initially, these technologies merely automated repetitive tasks. However, over the years, they have become more complex and integral to manufacturing processes. The advent of the Internet and digital technologies spurred the rapid growth of smart manufacturing, making factories more interconnected, facilitating extensive data collection and analytics. This evolution is ongoing, with new technologies continually emerging to further enhance production efficiency and flexibility. Today, smart manufacturing harnesses a variety of sophisticated technologies, including artificial intelligence, the Internet of Things, and robotics, automating processes and providing critical data and insights that fuel decision-making and foster innovation. At the heart of smart manufacturing lies artificial intelligence, or AI, which empowers machines to make decisions and enhance processes through learning and data analysis. AI's applications span predictive maintenance, quality control, and supply chain management. Another pivotal technology, the Internet of Things, or IoT, connects devices and machinery to amass vast amounts of data, essential for real-time monitoring, control, and optimization of manufacturing operations. IoT devices are instrumental in detecting inefficiencies and preventing downtime on production lines. Additionally, the role of robotics in manufacturing has evolved significantly. Robots are now more adaptable and capable of performing complex tasks with high precision. They collaborate with humans to boost productivity and safety, reducing human workload and increasing overall throughput. In the automotive industry, smart manufacturing has revolutionized production lines, with robots and AI systems collaborating to assemble parts precisely, minimizing errors and accelerating production. This integration not only optimizes manufacturing processes, but also elevates the overall vehicle quality. Similarly, the aerospace industry benefits from smart manufacturing, where advanced materials and high precision are paramount. AI-driven analytics and robotics ensure components meet stringent standards, crucial for safety and performance in aerospace applications. In the pharmaceutical sector, smart manufacturing extends beyond production. It also ensures adherence to strict regulatory standards. Automation and data analytics play key roles in maintaining consistent product quality and managing complex supply chains, which are vital in this heavily regulated industry. Sustainable manufacturing is becoming increasingly important. Smart technologies help reduce waste and energy consumption. For instance, predictive maintenance can prevent overuse of machinery, thus saving energy and reducing the carbon footprint of manufacturing activities. Water recycling and material reuse are also integrated into smart factories. These practices not only conserve resources, but also reduce the environmental impact of manufacturing processes. Advanced sensors and AI systems monitor and control the use of resources, ensuring optimal efficiency. Ethical sourcing and responsible manufacturing are part of sustainable practices. Smart manufacturing enables companies to trace the origins of materials and ensure they are sourced sustainably. This transparency is crucial for building trust with consumers and maintaining compliance with global environmental standards. Ethical considerations in smart manufacturing extend beyond environmental impact. They also include the treatment of workers and the implications of automation. As machines take on more tasks, it is vital to consider the social impact, particularly in terms of job displacement and workers' rights. Data security and privacy are critical ethical issues. With increased connectivity and data collection, protecting sensitive information is paramount. Manufacturers must implement robust cybersecurity measures to safeguard against breaches and ensure data integrity. Furthermore, ethical AI use in manufacturing requires algorithms to be fair and unbiased. Developers and operators must ensure that AI systems do not perpetuate biases or make unfair decisions, particularly when these decisions affect employment and workplace safety. Smart manufacturing does more than just change production processes, it transforms the workforce. New technologies require new skills. As a result, there is a growing demand for workers who are proficient in AI, robotics, and data analytics. However, this shift can also lead to job displacement as machines replace some manual tasks. It is essential for educational and training programs to adapt, preparing current and future workers for the changes. This adaptation helps mitigate unemployment risks and equips the workforce for new technological realities. Moreover, smart manufacturing creates higher quality jobs. These roles often require more critical thinking and problem-solving skills, which can lead to more fulfilling and engaging work. As industries adopt smart technologies, workers have the opportunity to advance their careers in exciting new directions. The demand for skilled professionals in smart manufacturing is set to increase. Careers in AI development, data analysis, system integration, and cybersecurity will be particularly valuable. These roles are crucial for developing, maintaining, and securing smart manufacturing systems. Sustainability experts and ethical compliance officers will also be in demand. As companies focus more on sustainable and ethical manufacturing practices, these professionals will play key roles in ensuring these practices are implemented effectively. Lastly, the educational sector will need to evolve to support this industry. This includes updating curriculums and offering specialized training in smart manufacturing technologies. Institutions that adapt quickly will provide their students with a significant advantage in the job market. Smart manufacturing is set to redefine the industrial landscape. With its focus on cutting-edge technologies, sustainability, and ethics, it presents exciting opportunities and challenges. The future of education in this field is crucial for preparing a workforce that is capable of navigating and shaping this new environment. As industries continue to adopt smart manufacturing practices, the impact on the workforce and the types of careers available will evolve. It is imperative that education systems keep pace with these changes to fully realize the potential of smart manufacturing. Ultimately, the integration of innovative technologies and sustainable practices will not only improve production efficiency and product quality, but also lead to a more ethical and environmentally friendly manufacturing sector. The future is bright for those who invest in the skills and knowledge of smart manufacturing.